You found a new dataset which you are excited to explore. In this video, I will talk about skills and steps required to perform exploratory data analysis in Python. If you're new to this channel, I'm Karina. I have transformed my career from finance to data and now I help others to do the same one step at a time. Let's begin. In this video, I will be using dataset I found at kaggle.com, link in the description. So it is e-commerce dataset for data analysis. If you look into the details about this dataset, you can see that it is synthetic data which was generated using Python Faker library. And because of that, I thought I need to show you how to generate data with ChatGPT. So if you want to practice your skills, if you need some data for mock-up reports in Power BI, for example, you can generate datasets with ChatGPT. If you know in advance what columns you want, for example, here we have a list of the columns we have in our dataset. So I used that and then I asked ChatGPT to generate me a new dataset. The prompt will look like this. Generate me data with number of rows that I can use for my data analysis. In this example, I said 200 rows, but you can say 20,000 rows, 2,000, whatever you need. And then I say it should contain the following columns. The name of the columns are used from that Kaggle dataset, and then at the end you say save it as CSV file. You can say save as PDF, Excel file, JSON, or whatever other format you want. And this is how the file looks like, so then you can use it for your data analysis. In case you don't know what columns your dataset should have, at first ask ChatGPT to help you with a list of columns. So I say I want to do exploratory analysis for retail store, so you at least indicate the industry you want to generate data for, and I need data for my analysis. Suggest what columns should my data include. And ChatGPT comes up with a list of columns explaining what they mean, and then you can go back to the very first prompt where you indicate how many rows you want and what columns you want, and the inspiration for your columns is the list generated by ChatGPT. The first step, we need to import libraries that we will be using to perform our exploratory data analysis. So we will be working with two libraries, Pandas and matplotlib. So we say import pandas as PD and import matplotlib.pyplot as plt. If you haven't done any other projects in Python before, it's your very first time, probably you need to install those libraries into your environment. For example, you run these two lines of code and you get an error that module not found. It means that you need to install the module first. And to do that, you say !pip install pandas. The next step, we need to read our file. I say df equals pd or pandas.read_csv, brackets in the brackets, a path to my file. I was recently asked how to get the path to my file. In my case, they are saved to downloads. I use Mac computer, but in Windows it will be something similar. I go to the file, right click, get info in my case, and this is the path. So I copy it as path name, and then I add backslash and add the name of the file. So when you combine it all together, that's how the file path looks like. Let's read it. And now if we say df and run this line of code, it shows us preview of our dataset. So we can see all the columns because our dataset doesn't have too many columns, but of course we don't see all the rows. So we see the rows from 0 to 4, then ... meaning there are more rows, and then we see our last rows. By default, Pandas display 10 rows, 5 first rows and 5 last rows, and it's the same for columns. So sometimes when your dataset has too many columns, it will display several columns at the beginning, then ... and then the last column. So you can't even see visually what columns you have. To change that, you can change the option display. So how it will look like? We say pd or pandas dot options dot display dot max rows equals and then the number of rows you want to display. By default it was 10. Let's change it to 6. Let's run it and let's rerun our df. And you see this time instead of 10 it displayed 6. It is very useful when you have a file that has a lot of columns but you can't see all of them. As I said, it will be displayed with ... In case you want to see all the column names, you can change this display option and change the number of columns, for example, to 200. And then it will display all the columns you have. To display maximum columns, we say pd.options.display.max_columns equals, and for example 200, and then in this preview screen you will see all the columns. If you want to see top rows of your dataset, we need to say .head. By default, it's always 5, but you can change the number of rows you want to display. In order to do that, in the brackets, you need to indicate the number of rows you want to display. For example, 3. And now we can see 3 top rows. You can change it to 10 or 20, whatever is more convenient for you. In order to see bottom rows, not top rows, we need to use dot tail brackets. And again, by default, it is 5. If you want to change a number of rows, you need to indicate the number in those brackets. If we want to see how many rows and columns your data frame has, we can use dot shape. So df dot shape, and let's run it. The first number indicates number of rows, and the second number indicates the number of columns of your dataset. If you want to see what columns you have, we can use df dot columns. This will give you the list of all the columns available in your dataset. If you want to see what data types your data has, we say df.dtypes. So we can see that our purchase date is object format. For example, you want to convert this data type to datetime. Our first column is customer ID and it is integer, same with transaction ID, it is integer, but for example, you want to convert it to string. This is possible. For example, net amount is float, but you can convert it to integer. We will convert our purchase date from object to datetime. To do that, we say pd or pandas dot to underscore datetime brackets. In the brackets, we say what we are converting. We're converting our column purchase date, comma, and then I indicate what format I'm converting to. In my case, it will be date, month, year, hour, minute, second. And we need to assign this value back to the original column, so those changes take place. And that's why we say name of our column, or df equals purchase date equals, and then this conversion. And now if we rerun our df types, you can see that our purchase date is in a date time format. If you want to display statistics for your numeric values, we can use .describe. So it will be df.describe brackets. Let's run it. And by default, it always displays only numeric column. So our customer ID, transaction ID, purchase date. So it shows us count, or how many values we have, then what is the average value, minimum, a maximum, our percentile, and also standard deviation. By default, .describe always includes only numeric values, but you can also say that you want to include, for example, objects. In that case, we say df.describe brackets, and then we need to say include equals object. And here again, you can see the count of values, how many unique values, top value, and the frequency. Similarly, we can use describe for only numbers. So if you say .describe brackets include number, it will display only the stats for the numbers. And if you want to see details for all the columns, in the brackets we need to say include equals all. And it will display you statistics for all 13 columns of our dataset. When you perform your data analysis, some of the columns actually have no meaningful information, and you can either ignore them or drop them. For example, your dataset has 40 columns and a lot of them have no meaningful information, or they are completely empty, so you can drop them, so it's easier to work with a smaller dataset. There are several options how you can drop the columns. One of them, remember, we used df.columns to see what columns we have. If you copy all of that, including square brackets, and now we say df square brackets and then paste names of all those columns, including square brackets, so you have 2 square brackets in this case. Let's run it. And it's exactly the same as df.columns. And now you can decide which columns you want to use and which not. So if you, for example, decide you don't want to use transaction ID, you can comment it out like this, or you can delete it completely. I prefer just commenting out. And then you need to assign it to a new data frame. You can assign it back to the original data frame with saying df equals. At the end, you need to also say copy brackets. This way Python knows that it is a brand new data frame and not a reference to old one. Or you can, for example, rename this data frame, for example, saying it df equals a new. Let's run it. Okay, I forgot to comment out one of the commas. Let's rerun again. And now if we print head of our new data frame, this is a new data frame that doesn't have columns transaction ID, doesn't have age group. Other option how you can drop columns that you don't want to use, using .drop. So you say name of the data frame or df .drop bracket. In the brackets you indicate the column or columns you want to drop, for example discount availed, comma, and then you need to say axis equals 1, so it knows to drop a column, not a row. When you perform your exploratory data analysis, you can also rename columns. For example, they are inconsistent or you don't like some names. To rename your columns, we can use .rename. So def .rename brackets, then we need to say columns equals, and we need to create a dictionary. To create a dictionary in Python, we always use curly brackets. Dictionary contains key value pairs. In this case, our key will be old name and our value will be new name. It's very convenient as you tell Python, this was the old name, please rename it to new name. For example, we have this purchase method, so you need to use this in quotes. And for example, we want to rename it to payment method. So we say payment method. And again, once you've finished with renaming all the columns, you need to assign it back to your original data frame. So at the beginning, we need to say df equals, in order to assign the changes back to the original data frame. Let's run it. And again, let's rerun df head to see how our data frame looks like. And we can see that purchase method was renamed to payment method. If you want to rename multiple columns, that .rename might look like this. If we want to check if our dataset has any NA values, we can use .isNA. df.isNA brackets .sum brackets. And it gives you a list of all your columns and if you have any NA values. By default, if you use df.isNA brackets, that's how it will display. It will give us every single cell in our data frame saying true or false, and it's very hard to work with. That's why we add .sum to get this summary that is easy to read. Similarly, if we want to check for duplicates in our dataset, we need to use .duplicated. And again, we will use .duplicated .sum brackets. Let's run it. And it shows 0, it shows that there are no duplicate values. But if you remove this .sum brackets, let's rerun it again, it gives us all the values saying true and false if there are any missing values, which is hard to read. That's why we use .sum to see the summary. In case we had duplicates, of course, you need to analyze why we have duplicates. Would it affect your analysis further? For example, a customer made several purchases. Of course, you will have duplicates in your customer ID column, but it is different transactions made on different days. So the whole row will not be duplicate, but if you look only at one column, you have some duplicates. So if you have a column gender, which has values like female and male, of course, if you look only at that column, you have some duplicate values, but if you look at the whole row, it will be different customer IDs, different purchases, transactions, so it's not duplicates. So you need to analyze further before removing your duplicates, but in case it is really duplicated value, you had some migration of databases, some error in the system, you have duplicate values, you want to remove them for your analysis, and to do that we need to say .drop duplicates. So the syntax will look like this: df.drop underscore duplicates brackets, in the brackets you say in place true. And why we say this in place true? To modify the data frame directly. So we're saying that the changes are applied in place to the original data frame. Let's look at summaries of our categorical data. For example, at our gender, age group, I will create new variables because then I will be using them for visuals. So for example, we say in gender counts equal df square brackets gender, in square brackets we indicate in the column, and dot value counts. And let's run it, and you can see that this dot value counts provide us with details for all different genders we have. So we can see how many values we have for female, male, and other. Similarly, we can do it for age group counts. We will do the same for product category counts, for our payment method counts, and for location counts. Now we will create visuals for our categorical data. Usually I create charts one by one, but in this example I will show you how to create several visuals at the same time, and they will be placed next to each other, which is very convenient, so you can make a screenshot and add it to your email, presentation, or portfolio. The very first step, we need to select the figure for our graph or the size of our charts. So we say plt.figure brackets fixed size equals 14 by 8. So it's width and height of our charts. We will have 4 charts, so I want 2 charts in a row. And for this, we will use something that's called a subplot. There are 3 integers that are passed as arguments to plt.subplot brackets. The first integer specifies the number of rows in the grid. I want 2 rows. The second integer specifies the number of columns in the grid. In my case, I also want 2 columns. And this third integer specifies the position of the current subplot. At the moment, we will be creating the very first graph. That's why here we say 1. And we will display gender counts. So we say gender counts, this variable that we've just created above. We say gender counts dot plot, in the brackets we say kind equals bar or bar chart, color sky blue, and then we need to indicate title, which will be gender distribution, and a Y label, which will be count. The second chart will be age group distribution. So again, we're starting with plt.subplot. We're saying that we have 2 rows, 2 columns, and it will be the second chart. Then we are selecting a variable which we are visualizing. In our case, it is age group counts dot plot. Again, kind bar, color this time is light green. So I want my charts have different colors, and then title and a Y label. The next visual is product category distribution. Again, subplot. This time we're saying number 3 because it will be the third chart. Here we indicate the variable we use, kind bar chart, and a color light coral. plt.title to indicate the title of our graph, plt.y label, again count, and our last visual will be payment method. So again, subplot 2,24 because it will be the fourth chart, indicating variable, changing the color of the visual, Y label, and title. Now we need to say plt.title_layout, and it is a matplotlib function that automatically adjusts the spacing between subplots to ensure they don't overlap. At the end, you need to say plt.show to display all the charts. Let's run it. And now we have all our 4 charts together. And the last part, we will analyze purchase trends over time. At first, we will create a column called purchase year months. We have a column purchase date, which we converted to datetime, and now we will create a new column called purchase year months. So we say df square brackets name of the column, in my case it will be purchase year months, equals name of the original column or purchase date dot dt dot to period m, meaning that we converting it to months. dt.toPeriod bracket is a Pandas function used to convert a datetime column in a data frame to a period that represents a specific frequency of time. In this specific example, it is months. Next step, we will group our purchase year months and count the number of purchases. We create a new variable called purchase trend equals df.groupBy. We are grouping by this new column, and dot size brackets. Dot size function in Pandas is used to return the number of rows in each group were applied after group by. So it counts the total number of entries or rows in each group. It is similar to how dot count works, but size brackets counts all rows, including those with missing values. And now let's plot the purchase trend over time. We start with selecting the figure size, so dot figure brackets fixed size 12 by 6. Then purchase trend dot plot, we creating a line chart, so we say kind equals line, marker equals O. You will see it is dots on the line chart, color will be blue, and then we need to add title for our chart. Then we add X label, Y label. I will add grid, so I say dot grid equals true, so we have the grid on our visual. X ticks rotation 45, so in this example we didn't do rotation, you can see the names, but when you add a rotation 45 degrees, those labels will change their position. And plt.show to display our visual. So this is the number of purchases over time. That's our graph. As you can see, it has grid, it has these markers, marker or it is those little dots, and you can see that X ticks were rotated by 45 degrees. And now we can create a summary report with all the data analysis we performed. So for example, we go back to our .describe and we can use this data for our summary report. For example, if we look at our discount amount, we can see that our average discount value is 137, while our maximum discount amount is 500. If you look at our total sales or gross sales, our average sale is 3012, minimum sale 136, and the maximum sale 8394. And if we look at our net amount, we can see again our average, our minimum, which is negative number. You can look into details why it is negative. Is it some adjustment, or we had a very big discount in this case? Again, then we can use details from value counts. We can say that gender distribution was like this. This is the number of female, male, and other. In this case, our dataset is relatively balanced across different genders. If you look at age group, we can see that most customers fall within the 25 to 45 age range, totaling 22,010, and the least represented group is 60. If you look at our product category, we can see that the most popular category is electronics with 16,574 rows. Other popular categories include clothing, beauty and health, and sports and fitness. If you look at our payment method, we can see that credit card is the most common method with 22,096 purchases. As for locations, most purchases are made in Mumbai, 11,197, and Delhi, 10,799. Then you can add charts to support your summary report. And then we have a line chart that shows the number of purchases over time aggregated by months. It helps us to identify peaks and drops in consumer activity, potentially influenced by seasonal factors, holidays, or special promotions. That's it for today. If you enjoyed this video, please click like and subscribe, and I hope to see you next time.